In this video, you're going to learn how to use the average acceleration formula to solve word problems. In this formula, we have four variables: A for acceleration, VF is V final or velocity, or the final velocity, VI is the initial velocity, T stands for elapsed time. Each of these problems, I'm going to give you three of the four variables, and you're going to need to solve for the fourth variable. So every problem we're going to start by reading and then labeling the given variables and labeling the unknown variables. Let's start with number one. A cat is running full speed, 7 meters per second, at a mouse. It takes the cat 4 seconds to come to a full stop as it devours the mouse. What is the cat's acceleration? Let's start with velocity initial. The first thing they give us is that the cat is initially traveling at 7 meters per second. Next thing they say is it takes 4 seconds to come to a full stop. The 4 seconds is your T. Velocity final, while this is not written there, comes to a full stop means that it's a 0 meters per second velocity. And they ask you at the end, what is the cat's acceleration? You're looking for A. It is important to always check to make sure your units line up. Meters per second, seconds, we're all set. Plug in your numbers that you know from the formula on the back. Velocity final minus velocity initial divided by the time. When you calculate this, you get negative 1.75. Now the units here are the top, the numerator is meters per second divided by seconds. That ends up being meters per second squared. That's your acceleration. Always make sense of the problem. Does it make sense that my acceleration is negative? In the case here, the answer is yes, because the cat is slowing down. It should be a negative acceleration because you're changing velocity by decreasing it. Let's go to the second problem. Top fuel dragsters are the fastest accelerating cars on Earth. They reach a velocity of 330 miles per hour in 3.7 seconds. What is their acceleration? Again, acceleration is what we're looking for. Time, 3.7 seconds. Final velocity is 330 miles per hour. You'll notice though that they didn't tell us what the initial velocity is. Assuming that the reader knows that a dragster is a drag racing car, they start at a complete standstill, 0 miles per hour, is your initial velocity. Before you plug in your numbers, double check the units. I have seconds, miles per hour. This needs to be converted to hours. How we convert seconds to hours, I'm going to find some spot in the margin here. 3.7 seconds, do some dimensional analysis. Seconds into hours, there are 3,600 seconds in 1 hour. So when you multiply and divide, you get approximately 0.001 hours. So that is now my new time, 0.001 hours. So A equals 330 minus 0 divided by 0.001. And your acceleration is approximately 330,000 miles per hour squared. Again, the acceleration is unit of distance per unit of time squared because you're taking a velocity and dividing it by another time. Number 3, find the time it takes for a car to slow down in seconds from 70 miles per hour to 25 miles per hour as it exits the freeway with acceleration of negative 450 miles per hour squared. Write down what we know. Velocity initial is 70 miles per hour. Velocity final is 25 miles per hour. That's stated from 70 to 25. The acceleration is given to us, negative 450 miles per hour squared. And we're looking for time in seconds. So when we find our time after we calculate here, we're going to have time in hours, so we'll have to convert it afterwards. It makes sense that our acceleration is negative, remember, because we are slowing down from 70 to 25. Plug in the numbers you know. So you're going to have negative 450. 25 minus 70 is a negative 45 over t. Remember we have the variable in the bottom or the denominator? You have a couple different options. First, you could multiply both sides by t and then divide by 450. Or you can cross multiply like a proportion. Negative 45 equals negative 450t. Then you divide by negative 450, which makes your time turn into a positive. Negative divided by negative is a positive. It's going to be 0.1 hours. Or if you convert it, your time will be 360 seconds. So in this case, we had to convert afterwards. Number 2, we had to convert before we started the problem. Just depends on the numbers you're given. And for example, here we had 1, 2, 3 items that have units in hours. If you want to do it beforehand, you would convert 3 things rather than just 1 thing at the end. It just makes it a little bit easier. All right, number 4, Mr. Kames Caprice Classic, aka really old car, accelerates at a rate of 400 miles per hour squared for 5 seconds. If the car was traveling at a velocity of 89 miles per hour at the end of the 5 seconds, then what was the initial velocity? So the initial velocity is what's trying to be found. We don't know what that is. Velocity final ended at 89 miles per hour. We have acceleration of 400 miles per hour squared. And then our time is 5 seconds. Check for units, seconds, hours, hour squared. We got to change 5 seconds into hours. When you do that and you convert, you get 0.0014 hours. That's your time. So plug in the numbers you know. 400 equals 89 minus initial velocity divided by 0.0014. All right, so we're solving for velocity initial here. We're going to multiply both sides by the denominator then to get rid of it. You get 0.56 on this side, and then 89 minus initial velocity. You're going to subtract 89 from both sides. When you do that, you get negative 88.44. And the last step, divide by negative 1. Just gives you the opposite number here. Velocity initial is 88.44 miles per hour. So, to recap, in all of these problems, I read through them, and I made sure I labeled all the information that I'm given, and then label the information that you're missing, and you plug in your numbers, and you solve for the missing variable. However, make sure before you plug in your variables, that you check for the units. You know, like for this example, we had no conversion to be done for number 1. Number 2, we did have to convert from seconds to hours. Same with number 3 at the end, from hours to seconds, and then from number 4 as well, from seconds to hours. Please be sure that you're looking at your units and making sure you convert them before you start. Once again, this is your equation. Velocity final minus velocity initial divided by time will be your average acceleration.